So you've probably used the suvat equations many times. You might even know them off by heart. But where do they come from? So the question is asking us to use calculus, using the fact that we've got a constant acceleration. So velocity is the integral of acceleration with respect to time. And remember that a is a constant, so when we integrate, we get at plus c, a constant of integration. So what we're going to assume is that when t equals 0, the velocity, the initial velocity is u, and then c will equal u. And we pop that back into there, and we get v equals at plus u. So this is confirming that integration calculus that we use for variable acceleration is consistent with suvat. What about the other one then? So displacement is the integral of velocity, and we've got an expression for velocity here now. So the integral of at plus u with respect to time, remembering that a and u are both constants. So the integral is half at squared plus ut, and then we get another constant of integration. To find out what that is, we assume that the initial displacement is 0. So then that makes c equals 0 and s equals half at squared plus ut. I'm so used to saying it the other way around. Okay, so we've done the first part of this, or first two parts of this question. Now we're asked to use this formula to derive the remaining two suvat equations. So let's start with that formula then, and we'll rearrange it in the following way. To get an expression for ut plus vt, when we rearrange that, we get ut equals 2s minus vt, and we can pop that into this equation here. So when we do that, we get s equals a half at squared plus 2s minus vt. A little bit of algebraic rearrangement gives us our familiar s equals vt minus a half at squared. So we're on the final straight now. We've got one more suvat equation to derive. If we take this as a starting point and rearrange that again in a different way, we get 2s over t equals u plus v. If we take this equation, then we can get an expression for v minus u. v minus u equals at. And then we can multiply these two equations together. The purpose of doing that is to eliminate the t. So we get v minus u times v plus u, and you can see we eliminate the t when we multiply those two things together. And that gives us v squared minus u squared equals 2as, or perhaps if you prefer, v squared equals u squared plus 2as. So there we are. We've got the variable acceleration approach using calculus is consistent with suvat, and that's how to get all of the suvat equations.